Super. So yeah, then good afternoon, everyone, or good morning, depending on where in the world you are right now. Thank you for joining us today for this exciting webinar on happiness, reactions of 10 countries to external shocks using big data. So we are thrilled to have you here. And it's amazing to see, many familiar faces and names, and especially my name. So please, again, if you want, rename yourself. If not, no problem. You can stay me. And I hope you will enjoy the session today. So before we dive into the topic, let me introduce myself. My name is Antje Jansch. I'm a postdoctoral researcher at the Leibniz Institute for Agricultural Development in Transition Countries, located in Halle in Germany. And for a year now, I've been leading the Leibniz Junior Research Group RuWell, which stands for Rural Being in Transition, Multidimensional Drivers and Effects on E-Mobility. And this project is funded by the Leibniz Association for 5 years in total. So the main objectives of this project is to develop a multidimensional well-being index with a special focus on place attachment. So we then plan to link this index to immobility decisions of rural populations in East Germany and Southeast Europe. Since this project is still in its early stages, we created this little webinar series to have the opportunity to share, to discuss, to get inspired by other researchers in this field. So I'm incredibly excited for our first session today, where friend and colleague Talita Greyling will talk about the Gross National Happiness Index, which is basically the brainchild of her and Stephanie Rousseau. And before I introduce Talita, I would like to encourage you throughout the webinar to actively participate. You can ask questions, share your thoughts, or seek clarifications by using the chat feature. We will address as many questions as possible during the Q&A session. You will also have the possibility to raise your hands, your virtual hands in the end. And if you want, switch on your cameras. Talita will talk for about 40 minutes, and after this, we will have time to discuss. So before we get started, I'd like to briefly introduce you, Talita. Actually, there's so much to say about you, but I try to keep it short. So Talita Greyling is a professor in the School of Economics at the University of Johannesburg in South Africa. She specializes in well-being economics and quality of life studies, and has a keen interest in fourth industrial revolution applications. She developed and established the Gross National Happiness.today Project, and the generated data and its index were accepted as official statistical data by Stats New Zealand, which is amazing. She is the vice president of the International Society for Quality of Life Studies, which is a global organization that promotes and encourages research in the field of quality of life. And it's a great society, by the way, so check it out if you want. She's also a member of the World Wellbeing Panel and a research fellow of the Global Labor Organization. She is the associate editor of the Journal of Applied Research in Quality of Life and co-editor of the Journal of Happiness Studies. So Talita, thank you so much for being here today and giving us insights into your research. I think the floor is yours, and let's get started.
Yeah.
Thanks.
Thank you very much for the very kind introduction. And it's wonderful to see you and everybody else. There's so many familiar faces and friends. It's great to see you. All right, but let's jump into this. Anke asked me to first just tell everybody a little bit more about the gross national happiness and how we actually construct the index, and then some application of that. So we're starting off with telling you a little bit more about the index. So that's the Gross National Happiness Index. And if you see that I'm looking at a different screen, I've got two screens here, and the one is enormous, so that I can see everything very nicely on the other screen. So what we're going to do is we're going to tell you what the GNH is, how we construct it, how we validate it, and are still busy validating and improving because it's research in progress. And then a little bit about the application of how we use this index. All right, so let's start off. What did I do now? I'm still there. Let's move on. Got it. All right, so just what is the Gross National Happiness Index? What we actually do is we construct data, time series data, high frequency. We can have it hourly or daily. And the way that we construct it is basically using a little bit of fourth industrial revolution. That's a nice word to use now because everybody likes that. But it's just using big data and natural language processing. I will explain a little bit more about that. At the moment, we are measuring it for 10 countries. So South Africa, Australia, New Zealand, and then you will see quite a few European countries. We've got Belgium, Germany, Great Britain, France, Italy, and the Netherlands. And why is that happening? Let's just go back one. All right. And then it depends on, at this stage, we've got those European countries because we worked with Static, our friends at Static, and that was our countries of interest at that stage. So we continued collecting data on them. And then during FIFA World Cup Soccer, we had a fun project where we actually measured the happiness of the countries, or some of the countries, we couldn't do all of them, that played the soccer. It was really fun. I looked at it, I watched every soccer game and lifted and shouted and was very happy to see the soccer. So I will tell you more about that as well. All right, now a little bit about how do we actually construct this index. So what we do is we extract tweets. So our whole index at this stage is built on tweets. Very soon it's going to be tweets and a few other things to make it more robust. So we extract tweets and it's at real time. So I wish I could show you the service we use, because we've got the service run the whole time, and you can see as the tweets come in, we extract about 1 million tweets per day, and we extract those tweets that's geolocated. So it's got a tag which says from where it's tweeted. And that's the reason we can actually then construct the data per country. Then the first thing we do is we determine the language that the tweet is in. So just for those 10 countries, there's 64 languages. We know at the moment, and that's when we started, we extracted on ASCII keys. At the moment, we are strictly on UTF-8, which means we can also read Arabic, any other type of alphabets, which is not a Latin alphabet. So those languages has increased. I mean, some of the languages I didn't even know existed. Then if we use a lexicon approach, a lexicon is like a library of words, and those words have already been beforehand coded as positive, negative, neutral, or the certain emotions that goes with. I don't know why it does this. Let's go back. What part did we go in? Okay, so certain emotions, and so it's a lexicon based. If we have a lexicon in the specific language, we will use that. If not, we translate it and we apply our English lexicons to that. And all right, so the sentiment analysis is really quite old. So it's something that sentiment analysis has been done for many, many, many years, even historically. At the moment, obviously, due to the vast volume of your text that we're analyzing, we're using natural language processing, which is a type of machine learning, going through the text and analyzing the tweets. We use a few lexicons. Now, the lexicons are those libraries. We use sentiment one then there's a bouquet of different lexicons, Sazoet, which is then Sazoet. In Sazoet, you have various ones. One that we use very often is NRC, which actually then codes the emotions. And then the one that we currently are using mostly is Beta. Beta is a little bit more sophisticated because it can also interpret the emotions of emojicons, for example, which is so often used. Okay, so how do we do it? I think once we have extracted a tweet, the tweet is coded. And as I said, it's getting codes of positive, negative, or neutral. And those codings we use then to, and we just put an equation, it's just a net effect. And from there, we derive the happiness. So negative, positive, and the difference, and a little bit more calculations to that. And we get the happiness. And the happiness you will also see on our website, which is the GNH.today website. And what you see there is the happiness scores, although we also have time series data for emotions, anger, anticipation, something like joy, trust, and so on. Right, so to get the time series data, we can aggregate the tweets coding and then the happiness scores either per day or per hour, depending on how we would like to use it. And then we just rescale the index so that it's on a scale from 0 to 10, with 0 being not happy at all, 5 is neutral, and anything above 5 is you are happy. Okay, then just some examples of where we can see, you know, what you watch the data, and I don't know, they always say that maybe it's a female thing, but you always want to know, have some confirmation that what you're doing is actually reflecting what you actually say is reflecting. And with sports events, we see it very nicely. With the soccer, you can see this is the game with Germany versus Costa Rica, where Germany won 4-2. And that is the happiness curve of Germany. And this is during the game. You can see where they started. The game started at 11 o'clock. Oh, now I'm going one ahead. Started at 11 o'clock. And then you can see how the happiness has actually increased from 11. And the game ended round about 1 o'clock. And you can see the average happiness in Germany is that dotted line. And there you can see the happiness is above the dotted line. And at some stage, it even went up to 10 max. So in Germany, there was a lot of happiness about the soccer. And we could see that in the index, reflected in the index. And that makes me very happy to see that. And as I said, I watched the soccer with the index on the one side and the game on the other side, on the other hand, and it was really exciting. I think especially the FIFA World Cup this year had so many surprises, which even made it more exciting. Then just to show you one of Argentina's, and I couldn't help to take the game where they actually lost the game. And you can see here the game started. And now what we have to do is obviously translate it into the time in Argentina. In this case, the game started at 6. So it was 7 o'clock in Argentina. And here the game started. It already had some anticipation, probably because they saw who's playing in the game or which members were selected to play. And then there is the average happiness in Argentina, and you can see what happened to this happiness. So it was far below the average happiness curve because nobody could believe that Argentina will lose against Saudi Arabia. Okay, and then I just had to show you something about South Africa because I'm South African, and the big game in South Africa is rugby. And this was in 2019. World Cup is coming up again now soon in France. And this is the game. This is where the game started in South Africa. And we were playing England. Now, people that know about the rugby knows that South Africa and England are quite strong rivals with rugby. We started watching, and England had a very, very good odds that they will win. And as the game went along, South Africa started scoring, and at the end of the game, 2 hours later, we had the highest gross national happiness ever measured, 7.9. Now, normally South Africa's happiness is about at 6.4. So the South Africans were really extremely happy with the win, and you can see that reflected in the index. So there's the index. Let's go on. Just some validity. So we've started looking at big data and the happiness index and doing some validations. We did internal validations, looking at time scale invariance. So in other words, what we do is we sample at real time, and then we will sample per hour, and we will sample every 6 hours and then per day to see if we get the same patterns. And we actually see we do. You can see you've got similar trends. And the volumes, we extract all the data and we will construct our index on all the data. I said plus minus 1 million tweets per day, but we then change the volumes with different volumes that we use. So with 5,000, 10,000, 20,000, 30,000 tweets used per day, and to see what it does if the volume changes. And you can see it's still following the same trends. Then we also did some external validity. So what we did is we took the Eurobarometer and we tried to get the average of certain countries and then also the average according to the Gross National Happiness. And we did plot it on a graph to see if we get some correlation, and we actually do. You will see that whatever the happiness was, say in France, Spain, Belgium, it correlates very well with what we find on the Gross National Happiness Project. We did more external validity checks. So we correlated the consumer confidence, which is calculated by the European Commission. And you can see there's also quite a strong positive correlation between the happiness index and that consumer index. More external validity. What we actually did here is we had the happiness index over time, over months, and we correlated with negative emotions, and we could see it's significantly and negatively related. The data we used here comes from Google LLC, so it comes from a specific paper that we used, where they also constructed some data, and there's also the external validity of this. Also, it reinforces that we can't say I can't say a good measure, but it seems to reflect the happiness within countries. Okay, so whenever I speak about our index and about big data, we always get so many questions about the validity of big data. How can you use big data? So these questions I get very often, and I need to answer them very often. But let's first look at the advantages. Number one, big data is available. You can get it on the web. So social media, newspaper clippings, there are so many sources to use. Normally to get them is free. To store them is not free, and to do anything where you start actually manipulating that data is really, there's costs involved, but not as closely as high as the cost of survey data. So it's much cheaper. The data is, I can almost say it's more objective data. It is subjective data because it's what people say, but the objective view of it, because if you have a survey, you will ask a person, they can sort of preempt what they want to, what the person that's asking the question want to hear. So it's not, there's some bias built into it. The Twitter data is also less vulnerable to small samples. As I said, we are extracting 1 million tweets per day. During the soccer, that went up to about 3 million tweets per day. So the samples are really big. And there are so many more advantages. For example, we are listening to a combined user. So it's not just only people or an individual, but it can also be companies, businesses, and their opinion. But there are many more advantages. Disadvantages. Now, this is questions I get really very often. The one that I get most often is it representative? No, it's not representative. Everybody in the world doesn't have a Twitter account. But if we compare to survey data, a survey, maybe it can be 1,500 people within a country. So is that always representative, or is the sample where we get 1 million tweets per country? We can decide about that. But so every type of data will have its limitations, and we recognize those limitations. So the one thing that we always say is there needs to be validation. We need to have survey data alongside our big data up to the time that we can be sure our big data measures what it intends to measure. And at some stage, we will only be using big data in the future, maybe quicker than we think. So big data is the route to go. Then big data, you've got a problem. You can't really pick up demographics. Although nowadays they actually do. There's many of the newer papers that go into gender and culture, getting that from the tweets. But it is harder. The geographical locations is relatively easy. It is just, yes, but as I said, they're even addressing that. And then representative, I've already discussed that. There's many more limitations that people will ask me about. And I think I've got the answers to many of them at this stage. But let's have a look at some of the applications. I just want to watch the time. All right. So in this case, we used the data, and this is real-time data. So during COVID, that was lovely, because in real time, we could see what happens to the happiness and emotions in the different countries during COVID. There were surveys and rapid surveys, but there was a lag, still months lag, where we had it in real time. We could see what's happening. So what we do in this paper is we analyze shocks, and these are macro shocks, to see what the shocks will do to the happiness of people, if the shock causes a change in the happiness, and then we also would like to see how big the shock is, how do the shocks compare, and then we want to see how quickly after a shock we adapt again to previous levels of happiness. So the first shock we are looking at is lockdown, and this is the first lockdown. Most countries had a lockdown to stop the spread of the virus. Now, this is an internal shock. It's not external shock. It's a macro shock, internal shock. The main purpose here was to save lives. So in other words, curb the spread of the virus. So this was the intent, but it was a shock on most people. And you will see just now when we start with the analysis. Then the other shock that we had 2 years later, a major shock, was the invasion of the Ukraine. That's an external shock. Nobody expected that, or did expect it, but the exact date wasn't sure. This is an enormous shock. It happened, except for the loss in lives, there were a lot of implications indirectly for the rest of Europe. We know what happened to the markets. We know that what happened to inflation, sunflower seed, oil prices increased, gas, a major problem for Europe. So we saw those effects. So these are the two shocks that we analyzed. I mentioned the aims, but we can quickly go through them again, determine the shocks, and of course, if these shocks actually had effect on happiness. We all know it had effect on the economy, but let's see about happiness. We compare the results of these two shocks. We test the adaptation, and then we also bring in the northern and southern hemisphere, some contrast to see what happens as we have the data for both. Then how do we do it? We use a difference in difference estimation technique to check the causality. So to make sure that it's the shocks that actually were the reasons for the dips in happiness. This is jumping out of its free will. And then we also do an event study. The event study is mainly also to see the adaptation, to see how quickly we can adjust to these after these shocks, adjust to previous levels of happiness. So the literature. Not much literature has been done on macro level shocks. There's literature on macro level shocks, and quite a few of them are on terrorism. I'm not going to go through all of them. And then obviously on COVID, quite a few, on the Boston bombing, and all of them find with a macro level shock, there's a shock, and at some stage, there's some adaptation, going back to previous levels of happiness within countries. So this is macro level. It is within a country, what happens due to a shock in a country. Then, if we look at the adaptation literature, all right, I'll move on. Now, we all know the hedonic treadmill theory, which says there's a set point of happiness. So something will happen, but in time, you will move back to the set point. This has been argued many times, and most often we find it's true. Some papers will find the opposite, or that you can really move into a lower happiness level. We all know how the paper with the lottery winners and those people that has lost some, the lottery winners and people that were bound to wheelchairs and what happens there. So that is the literature. And what we're actually doing is we're looking at both. So we're looking at macro level shocks, the impact of that, and we're looking at adaptation. So we will address both of these in the paper. Or just the contribution. There's previously 2 shocks, and the effects of 2 shocks have not been compared. And especially it's very different shocks. The one is internal, the other one is external. The internal shock, the purpose was to preserve life. The external shock was obviously to take away lives, to kill people like wars do. And then we tested the adaptation theory. And then the other contribution is we use this real-time data, which we are constructing at this stage. Okay, so the countries that we are including in this analysis is then the 10 countries on which we've got quite a long time series of data, which is then Belgium, Germany, Great Britain, France, Italy, the Netherlands, and Spain. And then from the Southern Hemisphere, Australia, New Zealand, and South Africa. Just to give you an idea, the time series data on the Southern Hemisphere is running already from 2019, and then on the European countries from 2020. So we're going for 3-4 years at this stage. All right, so for the shocks, what we use, the time period, is 2020 for the COVID. That's the first lockdown in most countries, was in 2020. And early in 2020, around about March, different countries locked it down on different dates. If you actually look at the paper, you will find all those dates. The second shock was in 2022. On the 24th of February, we had the invasion of the Ukraine. I must mention that the Ukraine, as you can see, is not part of our sample. So what we are measuring here is the indirect effects of the invasion. Let's do it again. So let's just go back. And then as a counterfactual period, we're using 2021. So 2021 to us is the ideal counterfactual for both of these events, because this is like the new normal. We already have COVID, we live with COVID, and we can use the exact same days that we had the lockdowns in the different countries and the exact same date, the 24th of February, and we have something to measure against where to see that when the shocks happened, if in the same year, the counterfactual, where it didn't happen, if there was any effect. So we have something to measure against. Interesting that we had reviewers complaining our paper is sort of in the last stages, we hope to be accepted. And one of the recommendations or the comments made by reviewers is, how can you use 2021 as a counterfactual for 2020? You should use the period thereafter. I went through all the statistics books. I went everywhere. Nowhere there's a rule that said your counterfactual must be the time period before the shock. It just says it must be a similar, the parallel assumption that you should have. So we will still see what the reviews say after they got our responses on this. We hope they're positive. All right, so the dependent variable in these analyses is the happiness index. We use some of the data from the Oxford tracker, so the COVID data, we use COVID cases, and then we use various fixed effects. We couldn't include much more than that, seeing that our time periods that we analyze is relatively short, so we've got a problem with degrees of freedom. Yes, so as well as, yes, I can't say much more about that. The methodology, the difference in difference. I think most of you as well-being economists will probably know the methodology, but the main thing to us is this interaction term. So this is the shock. So in other words, the lockdown or the invasion itself, and then the year in which the lockdown happened. If that interaction variable is negative, it means that in the year when the event happened, on the day when it happened, you had a worse outcome than in your counterfactual here. So that's our main variable of interest. We also then control for COVID. And then we've got all the fixed effects for the season, for countries, day of the week, interesting day of the week. We also found out with our happiness, Mondays lows, and then we have Fridays or Saturday high, depending on the country. And then obviously our standard errors, and we use robust standard errors to compensate for heteroscedasticity. Then you will see just now, we have the parallel assumption, and we can see that if we look at the years that we consider, so the year of the shock and the year of the counterfactual, we fulfill the parallel assumption, not exactly. So not perfectly. So let's say that when we actually discuss it, we must remember that. But if we consider a few other things, the lockdown dates differ in each country. And if we look at each country, we see the same happening. Happiness dips with the lockdown, and it's at different dates. So in my mind, if we have to say, if it's really the lockdown that causes the dip in happiness, if it happens in 10 different countries, I want to assume that it's got something to do with the lockdown. Then the reaction of the countries to the Ukraine, after the shock of the invasion, we see the same thing. Happiness in 10 different countries show a decrease. Once again, I don't think that it's just coincidence. I think that might be because there was a real shock. Then if we look at what happened around these shocks, the tweet volume increased. So this was really, these subjects were tweeted about, which also say it was a shock to people because they spoke about it. And if we actually look at the probability that these shocks caused the drop in happiness, we can also fulfill the positivity assumption. So we believe our difference in difference is identified. Then with the parallel assumption not maybe being perfect in the difference in difference, we also do some robustness tests with the event study to see if the week of the event is actually have lower levels of happiness than the weeks that follow. So we use the event study to look at that. And the event study also tells us more about the adaptation. So what happens, how quickly do people or countries recover from a shock? How long does it take? So testing the adaptation theory that we know so well. You can move on. So this is just the idea of the event study. So the week of the event will be coded as 0. And then we will have the weeks before the event will be -1, -3, -2, -1. And then we also look at the weeks after the event. We take 7 weeks after the event compared to see then how long it takes to adjust. Here's our graphs. This is just to show what happened. Here's the lockdown and here's the invasion. There's our counterfactual year, 2021. Now, what we did is the lockdowns in the different countries, we coded that as 0. And so on all of these countries, 0 was the date. And I forgot to mention, in our analysis, we didn't use the day of the lockdown. We actually used the day that the lockdown was announced, because the major shock we actually saw on the day that it was announced. We also, as a robustness test, did it on the day of the lockdown, which will normally be a little bit further in here. And we find the same results at the end. But here's the announcement date. You can see there's the counterfactual. There was the shock when they announced. Happiness decreased. And then after some while, it actually recovered again. So it adapted. If we look at the invasion, we see something similar. On day 0, 24 February, you see the shock. The depth of the shock actually increases after the invasion, when people fully start understanding or realizing the effect, especially remembering that this is not in the Ukraine itself or Russia itself, is not included in the sample, but it is countries outside of these. And here we find that at some stage we find some recovery, although here, I think what's happening here is we start realizing the full effect or indirect effects of the invasion. For example, the shortage of gas in Europe. But remembering that this graph is just the first view. In here, we're not controlling for anything. So let's look at the difference in difference estimation, where we can bring in some controls. We don't want to be at the results there yet. Let me just see what happened there. All right. Let's go back to, all right, just on the effect size, how big was these shocks if we measure it, and was it meaningful? So can we see a meaningful difference there? We do see that the lockdown shock was bigger than the invasion shock, but you will see when you look at the results, the lockdown shock was bigger and it was significant. If we look at the lockdown shock, it was over half of a standard deviation, and the invasion shock was almost a half of a standard deviation. If we want to compare it to, for example, the previous studies, Clark's study on the Boston bombing, they found it was a third of a standard deviation, which is really significant. So these shocks, the size, the physical size of these shocks are significant. Okay. This is our difference in difference analysis. And you will see I've got some highlight in green. And those highlights is our interaction variables, which are these coefficients is what is what actually is the major part of our findings. And we can see it's negative, which then means in the year of the lockdown, of the shock, on the day of the shock, people were less happy than compared to the counterfactual on the same day in the counterfactual here. So here we can see it's negative, it's significant, which to us means there's a causal, we actually prove causality, which says that the dip in the GNH or the happiness was due to the lockdown, that first lockdown or the announcement. If we look at the invasion, we get a similar result. So that interaction variable is negative. So on the day of the invasion, in the year of the invasion, or 2022, compared to the counterfactual 2021 on the same day, we find that the result is negative. I'll go back. So we definitely see a decrease in the happiness levels. Both are significant and negative. So the first question that we answered is, did the macro level shocks have an effect on happiness? We can say yes, it was significant, negative, and according to us, the causality, although we still have to say we interpret it with caution, but for us it seems that it was definitely the shocks that caused the dip in happiness. This is just to show you the same type of analysis for the North and the South. I'm going to skip over that. Let's have a look at then the event study. Now, the event study, you will remember that is mainly to test the robustness of our difference in difference. You can once again see week 0 is when the event actually happened. And now we want to see how quickly did happiness recover after that event. Here we've got the lockdown. And we can see the first week after the event, it's negative, though not significant. The second week, we already see it's positive. So here, happiness is higher than compared to week 0. And we see, so after week 2, happiness is basically recovered, adapted. So the adaptation theory is proven here. With the Ukraine, We see this is week 0, so our reference week. We see initially there's a dip, it's lower, although it's significant only at the 10% level. Another negative week, not significant. And from week 4 after invasion, we see adaptation. So it takes a little bit longer. And the reason we have here is because it's an indirect effect. COVID here was a direct effect. Let's just go back. COVID was a direct effect. People felt it immediately. And within 2 weeks, it recovered. Here with the invasion, the full effect was indirectly, and it took some time before people actually from the negative effect moved into adapted again to being happy. Here they realized the full effect over these weeks, and the happiness only returned in week 4. I'm not going to go to the north and the south results. All right, so the conclusions. What did we find? We find it doesn't matter what the shock is. It seems that the behavior of the people is very, very similar in both types of shocks. We see that the lockdown shock had a bigger effect than the invasion shock. In the difference in difference results, we strongly assume that these shocks caused the drop in happiness. The adaptation, we say that yes, your happiness adapted rather quickly, with a lockdown within 2 weeks, within the invasion within 4 weeks. People's, or the different countries' average happiness levels were back to normal levels, or assumed normal levels. So we can see this rapid return to the baseline. Okay, and then obviously limitations. Now we know about Twitter limitations about the data, and you probably will have some more questions about it. A big limitation is that we didn't have Ukraine and Russia in the sample. But what we assume is if they were in the sample, that effect that we would have seen, or that we saw, would have been much bigger. So we are actually, with that effect, we are downwards biased. And then in the future, we would like to analyze other shocks to see if we get a similar effect. So if all shocks actually have this effect on happiness, and if the adaptation is relatively quickly, that doesn't mean we want any more shocks at this stage. We don't wish that. But if anything happened, we are ready with real-time data to analyze that. And that is then the end of my presentation. Sorry, I took 5 minutes longer. And now we have time for questions.
Excellent. Thank you so much, Talita. Yeah, we have now a little bit more than, almost 15 minutes for discussion. So is there any questions for Talita? So you can either type in a chat or raise your hand. I cannot see something right now. So if there's no question right now, I have actually a question for you. And you didn't show, Talita, the results for the northern and southern hemisphere. But what I grasped something, that the effect to the invasion of the Ukraine is similarly high for both in southern and the northern hemisphere. I was just wondering that I wasn't expecting this. So I thought maybe like the effects are bigger in the northern hemisphere, because
let's see if we can get
people are maybe closer, geographically closer to the event.
That was the events effect. Let's see if we can get to the results.
Yes.
Is it that one?
Yes.
Okay. So what we actually find is the effect influenced the northern and southern hemisphere because it's an indirect effect. So a lot through the markers and the events that happen through the markers. In the southern hemisphere, we definitely saw the inflation rate due to certain of the products we couldn't get from the Ukraine any longer. So we definitely saw that effect, the negative effect, in the north and the south, and you can see the sizes similar. So that was quite interesting. And if we look at the paper, we actually comment on that. Then something interesting that relates to your question is on the event study. And this is more that the one lockdown. Now let's go to the invasion. You can see with the invasion in the north, you can see it's after 4 weeks we have the recovery, but then the south is only after 2 weeks. And that we can probably say is it's geographically the proximity to the invasion. So that's actually the only difference that we pick up between the north and the south and the full sample. I hope that answered your question.
Yes, yeah, definitely. There is a question in the chat from Antje Jansch. So, what were syntax conditions of tweets to be used for the analysis? Must the tweet contain the word happy, sad, or other words like that?
That is really an excellent question. So on these type of analysis, we actually extracted tweets on a keyword. So for the invasion, we use certain keywords like war, Putin, Ukraine, Russia, and then we extract the keywords and we look at the tweets and we read thousands of tweets to see what is the noise we pick up in the tweets. And then we use those tweets to construct the index. So it's based on the war. And for COVID, we did something similar. So you would have used the type of words that you will get around a lockdown to describe the lockdown. So announcement of the lockdown, we would have used anything related to that, the same thing. Then we started reading tweets and trying to pick up the noise. So what we say with pick up the noise is really looking at the tweets and if it is about the topic that we're actually working about or looking at. So that's the way we extract it. We extracted on keywords specifically there, and then we constructed our indices on those keywords.
Stefan?
I hope that answered the question.
So I can say yes. Stefan was the next one who raised his hand.
Hello. Yeah, thank you for this presentation. You mentioned that, of course, not everybody is sending tweets in all the countries. Do you know whether there is any research results on how tweet users differ from non-tweet users in terms of happiness? Is there any research on that? Do you know of any? And do you have a rough idea of what is the share in populations sending tweets actively in your countries?
Yes, we know the number of the number of tweet accounts. So, for example, South Africa, 11% of the population do have tweet accounts. And we mostly find that it depends on countries. So some countries will use Twitter a lot, some countries won't, but normally 10% or more, going up to about 20% of the population will have Twitter accounts. We've never compared the happiness of people that tweet to people that don't tweet. I wish we can. That's a very good idea. I don't know how to do it. I don't know if you can use two different social medias and compare that and be sure that it's not the people that tweet that also is on Facebook, for example. But that's an interesting question.
No, it would require a random selection in the population. And then you have surely some Twitter users and many non-Twitter users, and use a conventional survey with a random sampling. That could be a pathway. I thought maybe some people may have analyzed that already.
I haven't seen any paper like that. Maybe somebody that's listening at the moment has seen a paper similar to that, but that might be an idea, except that I'm not keen to do any surveys. So if somebody else is keen to do a survey and have the sources or resources to do it, I think that will be a super study, and it will actually then also contribute to validating or not validating our data.
Okay, so we have two more questions. First one by Ulf Dietrich Braumann. You were reporting on really huge populations and dramatic events. How do you think about the capability of your methods to also be applied on regional aspects of populations with extents of few orders of magnitude below yours?
Well, there's often questions about regional. Can we compare different regions? And once again, it's about the number of tweets we can extract from a region. For example, in South Africa, if we look at a big region like Gauteng, I think we can get a representative sample from there with enough tweets. But you need enough tweets to have a representative sample. We had Luxembourg in our sample, but with that, we found too much variation on the tweets. So the tweet number that we could extract there, which is Luxembourg, is very similar to one of our small provinces in South Africa, and we couldn't use that actually in our analysis. So our sample must really be big enough so that we can get a strong index which is robust. So if the region is big enough, we can do it. That's actually what we do. If there's enough tweeters in a region, we can build an index for them.
That's an excellent question. And Ayola Arapigini, next one. Thank you very much, Talita. Still did not get what was the issue with the counterfactual. Counterfactuals cannot precede a shock. And a second question, actually. What was the language of tweets analyzed? Did you translate tweets that were not originally in English?
The counterfactual is actually, I shouldn't even mention it. It is just that we get a critique because we used 2021 as a counterfactual for the lockdown year. And our reviewers say that actually a counterfactual must precede the year of the shock. And obviously in this case, it doesn't. It's the year after that. And then we went back into the theories of causality, and we found various indications that the counterfactual doesn't have to precede. It must just be a comparative year. So that was the first question. The second question was about languages. I think I mentioned it in my presentation. There are so many languages that we extract, and the lexicons that we use do have different languages, but it will be languages that's more often spoken. So there will be one for French, for example, there's one for German, and then we will use it in the language that the tweet occurs. But as soon as we get that, for example, Luxembourgish, there are really few people that speak it, so there we translate into English, and then we do the sentiment analysis.
Okay, I have also a quick question in between. You mentioned that you kind of analyze the tweets. And my question is, do you use like artificial intelligence to read those tweets to train the AI? Is there a possibility that like an AI pre-systematize tweets?
Yes. So there are different approaches to do text analyses. The one we use is the lexicon approach. And I will say that that's the older approach. So each tweet gets analyzed and you will gain the sentiment. So you will look at the different words and the combination of words, then you will derive the sentiment of the tweet. But the lexicon is based on a library of words which was previously coded with a certain sentiment or a certain emotion like anger, and then you derive it. Nowadays, what we do is we use machine learning, as you say, and we use different. So you've got your test data that you actually, or your training data set that you train. And most of that will be unsupervised. So they cluster certain words, give certain emotions to that. And then you will have your test data to test it. And then you will put it on unseen data. So we are moving into that, and you will be at ISQUAL, so you can see our first paper where we actually tested that. We found that the results using machine learning is most likely better than with your lexicons, but it's also, with the machine learning, it's still very new, very unexplored. So we're just beginning with those analyses, and we're using things like random forests. Some people go a little bit further and do some more complicated estimations. So we'll see what comes in the future and see what happens with text analysis.
Okay, thank you. There is two more questions. One again from Antje, like the first follow-up of her first question. Then follow up to a previous question. Do you assume that tweets containing, for example, Putin is bad, or Kiev needs more weapons associated with emotions?
Well, remember that we use a lexicon. So we don't analyze each tweet. And within the lexicon, certain words will have certain sentiment. And with that sentiment that they pick up in the words, you will find whatever the sentiment of the tweet is, the combination. And if you look at Vader, it won't just look at the word, but also where the word is placed. So, for example, love is positive. But if I say, I do not love you, it's negative. So with Vader, it will pick up those words. So it's not up to me to say if it's negative or positive. We use natural language processing, which then look at that, and we actually get the result. So we work with the score. Is it 2, 0, or 4, for example?
We're approaching now the end, so I have like one last question, unless there's a very urgent one. You still have the chance, but for now I read like Johnson Kansimis question. If I have the opportunity to access the raw data that you extract from Twitter, can I replicate your index and reproduce similar results using a different software like Stata or R? Disclaimer, I am not well versed with machine learning.
Well, that is the idea, is that you can replicate our findings, and if you have access to our raw data. But with in Stata, we don't really have a lexicon that we can use, so our coding is mostly in R. So if you use our R and you use our coding, then you should get the same result as we do. We'll be following the rules, so yes. Is that the answer, or did I fully answer that question?
I say yes on behalf of Johnson. I don't know, unless you want to say something.
Yes, it did. Yeah, thanks, Talita.
Good.
Okay. Is there any more questions?
Maybe one last more question, Talita. Is it possible that someone can, or is it possible that you can avail anyone access to the raw data that you generate from Twitter? I know that there could be data protection issues, but is it possible that someone can access the raw data that you collect over time from the different countries? Because I can imagine maybe you have an Excel file or something like this. I don't know. I'm just trying to think out loud. Thanks.
We don't share. We're not that type of researchers. That was a joke. No, the data that we extract is available. I mean, we extract it at real time. At the moment, I know that we have about 1.5 terabyte of data. So it's not on the Excel spreadsheet. It's really, we're speaking about big data here. And obviously, we are doing research. And for us, the main thing is to validate big data. As I say, it's the future. This is at some stage we can have GDP in big data, and it's not even the future. It's being done at the moment with nowcasting. We nowcast GDP. So the point is, the more researchers working on big data, validating it, getting it stronger, getting it more robust, the better, because that's where we're moving to.
Okay, so we are having one last question, I would say, and then we finish the session. Okay, Kabeya, I hope I pronounce your name right.
Yes, it's Clement. Yeah, thank you very much. Thank you very much, Talita, for the wonderful presentation.
Clement, it's great to see you. It's one of my colleagues at the University of Johannesburg.
Okay, no, thank you very much. I just want to know, can you also construct these indices at the regional level? Let's say you take a country, instead of considering an index for the country, but you can have an index for the regions in the country, or even sub-region, like you can go to the district. The reason why I'm asking so, as you know, I like introducing spatial dimension in the data. I wanted to see, for instance, if it will be possible when there is a shock, how do people or regions respond to the shock differently? So I don't know if in your data that possibility is there, because since you are collecting data which are georeferenced, do you have that possibility? Thank you very much.
If you extract a tweet, we only extract geotag tweets. So there's a choice that you can say if you actually do want to make it known from where you tweet. So we extract those tweets. And then there's also a place in that tweet. And the place will say from which town or region. So for example, for South Africa, we can actually place which were tweeted from Johannesburg and which were tweeted from Cape Town. So if you actually go and cluster those accordingly, we will have for a region. So it's possible. And for South Africa, our bigger provinces, we find enough tweets. So for Gauteng, for example, or KwaZulu-Natal, we will have enough tweets that we can do it. But it's really on the tweet volume. If there's enough tweets, we can build an index. If there's not enough tweets, we don't get a robust measure. Okay. So yes, Clement, we can do something on that, and you can do the spatial analysis. He's excellent with all the spatial econometrics, so we can have a look into that.
Thank you very much, Talita.
Actually, Peter, you put me in a position, you know. Is there a last question after a last question? I don't know. I mean, we started a little later due to technical problems. Talita, is it okay? One last question.
Yes.
Yes.
It's so wonderful to see Peter. If I could, I would have hugged him. Give him a big Bluetooth hug.
Nice. Okay, Peter, you have the okay.
Talita, I hope very much when you come to Rotterdam, and I hope so that we can have a coffee there.
Yes, please.
Not just to the last question, that might be also interesting for East Germany, if you look at invasion effect, because we have different notions between East and West. So it might be quite interesting if it is possible just to separate it. So I keep it very short. And again, thank you very much for your very interesting. I have a couple of further questions, but I think the Bark and Bites is not your note. So thank
Peter,
you.
we will discuss that over coffee in Rotterdam.
Yes.
That would be very interesting to do that, because we have in Germany, we have more than sufficient tweets. We're able to actually separate them, divide them between the East and the West. I mean, it's things that we didn't even think about, but that should be very interesting to see the different effects of the shock and if it was the same or not. I think that will be a very good paper.
Sounds beautiful, yes. Okay. And okay. I think Antje will really enjoy this topic also.
Yes. Definitely, I'm into that coffee session with you.
Yes, and I wish we can collect more data from Eastern Europe, because to have an idea of what happens there, I mean, they are more affected. But at the moment, it's all about resources. So I really hope that we can extend it and have more countries included soon.
Yeah. Talita, okay, I will now close that session. I thank you so much that you were here, that you presented this interesting paper. Thank you very much. I appreciate that a lot, and I think all the other people too. And yeah, I wish you all a great evening, and see you hopefully tomorrow. or the day after tomorrow, we have also like 2 other interesting presenters. So check it out on our website. There's more information and register. And then you get the right link and you don't, and you have the right name. Okay, thank you so much.
Antje, thank you very much for the invitation. I feel really honored that you did invite me and you gave me the opportunity to share some of our research.
Yeah, always. Okay.
Thank you, and see you soon.
See you soon. Bye.
Well, bye-bye.